A quick bit of chat this morning about the MCM modifications and the system modifications for the 96 Cell LTO pack, which you have seen me working on over the last few months. It's been working very, very well the last week or so. I have no IMA errors, and it's all been fairly consistently very powerful, as you can imagine. And there's still a couple of little tweaks to go, but this is where we are at the moment. Obviously, I've been making tweaks and changes to the system as I've been going along to try and improve it, and I'm improving the software and the hardware, just making little incremental improvements until I get it where I want it to be. So we'll just have a quick look inside this MCM and see what we've got. So first of all, we've got an IMA CNC manual control board, and this one is actually linked to a BCM interceptor, which is also fitted inside the MCM here. So with the OBD2 CNC sending special commands to the IMA CNC, I can set the ALF and RLF flags to prevent assist or regen. So this basically connects to the BCM interceptor via the programming pins, but they're also linked to pins 1 and 2 on the connector J3, which you'll be familiar with. So the BCM interceptor is also doing the fixed 75% state of charge. It also has the voltage, pack voltage monitoring active, and it also has the faked 25° centigrade for maximum performance. And the IMA CNC is pretty standard, apart from obviously that connection which goes to the BCM interceptor. So then on the back of the connections here, you can see there's lots and lots of connections, but remember this is an MCM. It's been reused lots of times, lots of different mods to this. Most of these are power and communications wires. I have done the FSC fail short circuit mod on this MCM so that the car can't throw a code if the IGB decides the current is too high. That occasionally can happen when assist is very, very high or regen is very high at low RPM, but by disabling that, the IGBT still protects itself, but you just don't get an IMA code and you don't have to reset the system, so that's just convenient. So then what do we have? Well, we have a little switch here at the side, and this is an activation switch for the or disable switch, if you like, for the 120 volt fixed voltage hack maximum power mode. So if I want to disable that manually, physically, I can turn the switch, and then even if the IMA CNC tries to command the maximum 120 volt high power mode, then it can't do it because that signal has to pass through this switch. It just saves me faffing around reprogramming my CNC. If I want to disable that, I can just throw the switch. So this MCM also has a plus 40% current mod. That PCB is installed on the other side of this printed circuit board, as you're probably familiar with. It's that little tiny one with the dip switches on, and that's all wired in. So then we get to this circuit here. Now this is the latest incarnation of the V-pin modifying circuit. So the V-pin is the voltage from the motor drive module which comes into the MCM. It's an 0 to 5 volt analog signal proportional to the MDM voltage, high voltage. It comes in here and it passes through, and normally it just goes straight into the board and is sensed by the car, and that's where we get the MDM voltage from. So, but this we have a two-stage setup here, and this V-pin here has a 33k resistor in the line when it comes in, and that's to drop the voltage down to where it needs to be for the system to operate. So obviously my resting voltage might be 240 volts equivalent, and so this drops that down to the equivalent voltage in a 0 to 5 volt scale. And then we have an op-amp buffer here, and this buffers the voltage and outputs it back to the V-pin into the MCM. So what we have for this buffer, though, we have two inputs to this buffer. We have the input from the 33k resistor from the MDM itself, and we also have a fixed value, 120 volts. Yes, the 120 volts fixed value, which is used for the maximum power mode. We know the MCM allows maximum power and maximum current when the battery voltage is just about 120 volts or just slightly over. So this is what this system does. But now we've introduced the solid state switching. Previously I had a little relay activated circuit here, which was the previous incarnation. I've just taken that out. So now we have the single pole double throw electronic switching here, logic level switching. So this switches basically the input to this buffer between the fixed 120 volt and the live V-pin voltage from the MDM. And also when the signal from the IMA CNC comes in to say switch, it also sends a signal down to the BCM fooler, and system over here, and I'll tell you about that in a second. But the idea was to keep these all very isolated, so this is all 5 volt here, and 5 volt going out on this wire here, and all the high voltage in this separate little box here. So this is a standard 10k BCM fooler here, but it's wired up via this device here, and this is basically exactly the same as the V-pin setup really, but this uses opto couplers to activate the system. So the first thing about this is that the high voltage from the battery comes in on this wire here, and the high voltage to the battery is not connected to the BCM fooler unless the ignition is on. There's an opto coupler here which turns on when the 5 volt power in the MCM comes alive, and it connects the opto coupler up. There's a 33k resistor here, and then that drops the voltage down for the BCM fooler to give an equivalent voltage to the system over here. So that's our normal voltage, and that's only active when the 5 volt is active, so that means you don't get the parasitic drain of the 100k BCM fooler across the battery at all times, which we don't really want. Now there's a second opto coupler here, and it brings in this Zener diode here. So when you ask for 120 volts, it brings in this 120 volt Zener diode into the circuit and pulls down the output to the BCM fooler to 120 volts. So that's how we generate the 120 volts across here. We basically just introduce this Zener diode into the circuit. This is all fused by a 250 volt rated DC fuse. So that's the high voltage bit, and it all sits in this little box here, so it's separate, and the only control wires going to it are 5 volt opto isolated wires here, and there's some opto isolation on the bottom of this board, the opto isolators, and they basically keep the control and the 5 volt signal away from the MCM, which has improved the system quite a lot. And also we haven't had the short circuit or short to chassis code for some time, so that seems to have been cured possibly by a combination of more careful isolation. This has been coated with conformal acrylic coating as well to improve the isolation and leakage resistances, etc. And obviously rebuilding the snubber units, which you saw on an earlier video. So this is all going to go back in the car very shortly, and some more road testing. The final mod for ultimate power, I mean this is already giving 26 kilowatts, which is an enormous amount of power, and it is very, very lively to drive. The only other thing you could possibly do is increase the current hack from 40 to 50% during hard acceleration, and you would have to do that using switching again. So you would have a switch here, and you'd have to have some switching resistors to pull the various current sensor resistors to different values. So that's something that can possibly be looked at. I might look at doing that with something like one of these switches, or a multi-pole version of it. So that's where we are at the moment. The whole electronics is up and running, and I'm just about to now test this latest solid state version of the V-pin circuit.